Okay, we're on number 6. A certain function is represented by this table of numbers. Okay, so we've done these things before. I think we're going to need the white marker. We have that. And let's make sure we have the right size. Okay, so we have our table. Let's write it out. X and Y, and we have 0 and 0. We know what that is. But then we have 1 and -1. Then we have 2 and -2. Well, that's interesting. Then we have 3 and -3. Then we have 4 and again another -4. And so it seems like these numbers are similar, just we're getting negatives of the other, or the opposite, let's just call it. We'll learn more about opposites. So we have our table, and we're told to graph this function by drawing a pair of axes and plotting these points. Now, when we're drawing graphs, and let me get my black marker now. When we're drawing graphs, we need to look at our table first, because we need to understand to what extent, where do these things extend, and we see 5. 5 is the highest number. So if I were to draw, I might just go out to 5, going in each direction, knowing that wherever I'm plotting these things, I'm going to end up at least within the graph, okay? Now you could look and see a pattern here and say, well, I know that I'm going to go +5, -5, so if you know you're going to be within a certain quadrant, and this will all fall within a certain quadrant, you could just sort of focus on that quadrant and save yourself the paper. But it's okay in the beginning. Usually just go 5, 5, 5, 5 in each direction, and you should be fine. Now, our first point is 0, 0, so let's go ahead and plot that. All right, and our next point is it's 1, -1, so that puts us down here in the fourth quadrant. Our next point is +2. Again, it's positive, but then it goes -2, so we're going down into the fourth quadrant again. Then it's +3 on the x, and then -3 going down. So, oh, I see a pattern here. And you can see there's going to be a 4 and a -4. So we'll always go horizontally first. Remember, that's the x value. So we go +5, -5. So what do we have here? Well, we have, if we were to graph this, and we were to draw a graph of this, we would be able to just simply connect this, because it says that it's a function. We've plotted some of these points. There aren't any limitations, so we could say that we just draw a line of this, and I would say it would look something like this. All right, and it would include all of our points and beyond. Okay, we've only plotted these points in particular. In fact, let me redo that, and let's try to preserve. I'm going to change to red and make this just slightly thinner. So let's see if I can do this again. I think I was here, and that might be the line. Okay, so our line is there. We've got our points, and our next challenge is for us to write a formula. Now, we know that that's a challenge. We do also know some things, particularly like the types of graphs that we're dealing with. And notice that this is a straight line that crosses through the intersection, right? So there's a hint there. It's a direct variation. It's a direct variation, meaning I can write this in the form of y is equal to ax. All right? Now, if we were to take a look at this, we would say, well, what are we doing to x that's going to create the y value? Now, when we have 0 here, it's hard to tell. We know that because we're multiplying by 0. But in this case, what would we do to 1 to make it -1? What would we multiply? Well, we would multiply by -1, wouldn't we? Same thing would happen here. Multiply 2 by -1, and we get -2. Multiply 3 by -1, -3, and so on, all the way down. So we could write y is equal to -1x, okay? Now, if we left it like this, we didn't necessarily simplify because anything times 1 is itself. We could simplify this by just simply getting the negative 1 out of the way and saying y is equal to negative x. Now we couldn't just remove the negative, but it's implied that 1 is always in there, whether it's positive or negative. So y is equal to negative x. Now you might say, well, what do you mean by that? Well, let's just plug in the value. Let's say y is equal to negative x. What is x? Negative 1. So then that means, oh, excuse me, we have 1 for the first one. I'm going to put this in parentheses because we know that's the x value. And what is negative 1? Well, it's negative 1, right? That's what y is. Negative 1 is negative 1. Now, remember, this is the x value inside of the parentheses, not the negative. We're taking the opposite or the negative of the x value. The negative or the opposite of positive 1 is negative 1. So that's what you would do. So that would be our formula. Now we're also told to draw a line through the points and extend it to the second quadrant, which, oops, we've already done. We extended it to the second quadrant. Sorry for jumping the gun there. Let me just go back and get my marker. Now remember, this is the first quadrant. Where would the second quadrant be? Is it down here? No. Counterclockwise. This is the second quadrant. This is our third quadrant. This is our fourth. So the points that we plotted earlier, with the exception of the first one, which is on the origin, were all in the fourth quadrant. So had we drawn this, we would have drawn it. Well, we could have drawn either way, but they wanted us to extend it. So the second quadrant meant we would have extended this line out to here. Okay, and remember, it has to be a perfectly straight line. Okay, we could not have drawn this line, for instance, let's see, and had gone, slightly this way. No, that's not a straight line. The line had to be connecting these and continue to be a straight line. So if we would have drawn the line just to here, we could have connected them, or we could have gone all the way into the second quadrant, and that's a perfectly straight line. Now notice, just to keep things in check, we could plot other points, and that's what they ask us. Copy and complete this table referring to your graph. So what are they giving us? They're giving us more points, and we want to finish the table. So let's go ahead and remove this part right here. Just get it out of the way. And we can now go ahead and plot our next table. Well, we could leave the formula, but we'll just write it back in there. What was our formula? It was y is equal to negative x. And now we have another table, x and y values, right? And we had negative 5, negative 4, negative 3, negative 2, and negative 1. Now, they say that we can refer to the graph, okay? And if you do look at the graph, you're going to notice something in particular. Where is negative 5 going to be? Well, we have to move to the left on our x-axis and go out to negative 5. What y coordinate is at this point? Well, we have to go find that coordinate. We go all the way up and look where it is. It's actually positive 5. So this would be our point. So our y value would be 5. For this coordinate, negative 5, which is here, I'm going to get my black marker again and just plot that point. And that would be here. In fact, when we look at negative 4, we can find its value here. Negative 3 is here. Negative 2 and negative 1. We're going to look for these values. Well, what are these values as we go across? Well, here's negative 4. You've got to go all the way up to positive 4. So we'd write 4, positive 4. And then negative 3 would be up to positive 3. And as you can see, it keeps with the same pattern. Negative 2, positive 2. negative 1, positive 1. And when I say pattern, it's the opposite. It's the y is equal to negative x formula. So what's the negative of negative 5? Well, what's negative 1 times negative 5? We could actually write that. Okay, negative 1, or the negative times negative 5, well, that would be positive 5. Okay, or we could have written this, as we will be doing in our next few chapters. We'll be writing negative of negative 5, the opposite of negative 5, or again, positive 5. So we could look at it either way. We can use that 1, and that kind of helps us to understand it's negative 1 times negative 5, and we know that a negative is times a negative yields a positive, and 1 times 5 is 5, so in this case it's again the opposite. So and we can see that pattern all the way through the rest of these numbers.